Hello everyone! Today I would like to tell you about such an unusual metal as europium. Europium is a pretty active so-called F metal belonging to the lanthanide series in the periodic table of chemical elements. This is a very active metal, and its chemical activity can be compared to that of lithium. That is why it is stored in containers with inert atmosphere to protect europium from oxidation. By the way, europium metal is paramagnetic and gets attracted to powerful neodymium magnet, and also this metal is very expensive. I paid $20 for 1 gram of this metal. When taken out of its container, europium is a shiny metal that quickly covers in its oxide and yellow europium carbonate. This separated soft metal. Europium can easily be cut with pliers. Its softness can be compared to that of lead. Europium actively reacts with water like lithium or calcium, forming polysoluble europium hydroxide of yellow color. As time passes by, the metal covers in thick layer of hydroxide and the reaction slows down. If mixed with hydrochloric acid, the reaction significantly speeds up, because europium dissolves in hydrochloric acid very well, producing yellow europium chloride. By the way, I was surprised by the property of europium chloride. Freshly made solution of this substance fully blocks ultraviolet light when being pointed at with an ultraviolet laser, which is pretty strange, because usually europium salts glow in ultraviolet light. This effect is well observed if one tries to pass a beam of ultraviolet laser through europium chloride solution, with a flask filled with luminophore solution behind it, from green emitting luminophore. Even more interestingly, when the solution had been stored in a dark place for a couple of days, it began glowing red-orange in ultraviolet light and stopped blocking ultraviolet laser beams. I think this effect is somehow linked to the fact that the radius of europium atoms is large and the atoms have f orbitals. Let's move on. If you mix alkali or sodium hydroxide with europium chloride, it will form yellow sediment from europium hydroxide. As many other lanthanide hydroxides, europium hydroxide dissolves in trilone B, a teapot limescale remover, forming soluble agent. If you try to set a piece of europium metal on fire out in air, despite your expectations, it wouldn't burn, although its chemical activity should cause it to. I think it's so due to the high melting point of this metal. Upon piercing europium in air, it forms europium oxide that also gives the flame of the burner a red color. This oxide, as well as europium chloride, glows red in ultraviolet light. Europium oxide, as well as its other compounds, make up well-known luminophore powder based on strontium aluminate. These differently colored powders that are abundantly sold via the internet have a unique property. Such powder glows in ultraviolet light and also accumulates light energy, and it can glow for a few hours after the light was turned off. Such powder are used in applied arts, and they are also added to lots dyes, especially those that are used to paint clocks' hand tips that glow in the dark. Europium is an afterglow activator in such powders, and it also increases brightness of the residual light. The color of the powders depends on its content. To get other colors, other rare earth metals compounds are added. Europium oxide is also used in picture tubes to make red pixels, and also in order to make fluorescent lamps light warmer. Europium is also used to protect the dies of euro banknotes. Europium protects euros. What an interesting coincidence. Perhaps californium is used to protect dollars. If you would like to support the continuous production of science videos like this one, please support channel on Patreon, link in the video description. Please like this video and subscribe to my channel to see many more new and interesting